Hello, this is John Labaon, and today we're going to deal with another problem, which is our transistor, and we were asked to determine the following for the fixed bias configuration and show our solution. So we are asked to find the maximum base current, the maximum collector current, the maximum voltage of from the collector and the emitter, and the base voltage, the emitter voltage, and the collector voltage. And we were given some initial or expected answers down here. So not to delay it, we will start our solvings. So this structure here of our transistor, we will rewrite this into this one. So we get a 510 kilo ohms and 1.8 kilo ohms, and uh, we were given a beta which is equal to 120. So since we assume that this is a silicon, so we have a value of 0.7, and we will deal with this later on. So we start with KVL in the loop. So we get negative 16 plus 510 kilo ohms multiplied to our base current plus 0.7 is equal to 0. So by transposing this 16 and 0.7, we get 16 minus 0.7, divide both sides by 510 kilo ohms. So we get the value of our IB, which is equal to 30 by 10 to the power of negative 6, or 30 microampere. So we already get the value of our A, which is the maximum base current. And next is um, the value of our collector current. So the formula of that is beta times the base current. So we have 120 times 30 by 10 to the power of negative 6. So we get 3.6 milliamperes, which is also the same with our expected answers here. So 3.6 milliamperes. So therefore, our transistor is an ideal transistor. So our V, or the emitter voltage, is equal to 0. So our uh, voltage of our base and emitter is equal to 0.7, and VB minus emitter voltage is equal to 0.7. So we get the value of our base voltage, which is 0.7 volts. So next is so we get the value of our VB, which is 0.7, and emitter voltage, which is 0. So we get our expected values here. So next is we will get the value of our collector voltage, and the formula for that is uh, the collector supply voltage minus the collector current and our RC. So VC is equal to 16 minus 3.6 by 10 to the power of negative 3 times 1.8 by 10 to the power of 3. So in other words, is 16 minus 3.6 milliamps and 1.8 kilo ohms. So the value of our collector voltage is 9.52 voltage, and we will see if it is the same with our expected answer. So our collector voltage is 0.48 here. So we can see this is not the same, but as our teacher said, one of the answer is not correct. So I guess this is the one which is correct. So we will get the value of our um, VCE, which is the voltage of our collector and emitter. And the formula of this is the collector voltage minus the emitter voltage, and that is equal to uh, 9.52. So our VCQ, or um, VCEQ, is equal to 9.52. Therefore, our VC and VCEQ, or the maximum collector and emitter voltage, is the same. So therefore, our F and C is the one who have the wrong answer here. So this this should be 9.52 volts. So that's all for today. Thank you, and I hope you enjoyed my discussion. So bye bye.